So we are going to be working with quadratics with complex solutions. Most of the time we're going to be using the quadratic formula. That's not the only way you can use solving, and I'll show you how to do that at the end. Today's assignment, you can use factoring, you can use solving for x squared and go from there, or quadratic formula, whichever of the three works best for you. And so those are the three options you'll have available to you. So when we're working with quadratics with complex solutions, that means it's going to have an imaginary number with it as a possibility. When we did quadratic formula and we ended up with the discriminant coming out to be negative, we said there was no real solutions. Today we're talking about what those solutions are. They're not real solutions, they're imaginary solutions. And we are going to work through it the same process I used the quadratic formula then. It's still working today. We're just going to add in the feature that we did yesterday. You know how we end up with the eyes being pulled out? We're going to have that same thing that's going to happen today. We're going to pull out those eyes when we're working with the discriminant and simplifying the discriminant going into the square root. And so when we're looking at this, let's take this first problem. We have 10x minus 11 equals 8x squared. And so we need to figure out how to solve this. We need to find our a, b, and c. Do we have everything on one side and so that we can?
No.
Which side do you want to move it to?
To the left.
Move it to the left. That's going to create a negative for your a, which is fine if you're using quadratic formula. Okay? It's not the best, but you can. So we can minus 8x squared minus 8x squared. And that's going to create negative 8x squared plus 10x minus 11 equals 0. If you don't want to deal with your a being negative, we can divide every single term by -1. And I would recommend doing that just because having the a negative does cause problems. For people most of the time, they'll mess up in simplification. And so that's going to give you 8x squared minus 10x plus 11 equals 0. So let's identify a, b, and c. A is in front of your squared term. So what's in front of your squared term? 8. B is in front of your variable without a square.
-3.
And c is your constant. And so we're going to take this information, we're going to plug it into the discriminant, and we're going to work from there. So the discriminant is b squared minus 4ac. And so we're going to plug in a b squared, so that's going to be a negative 10 squared minus 4 times a, which is 8, times c, which is 11. Be careful when you're typing this in the calculator. This is something I keep seeing y'all when y'all are going back and having troubles with your quadratics. A lot of you were having troubles remembering to put a negative in parentheses when you're squaring it. If you don't, the calculator does not know exactly how to think about it. They think about it as a negative, and then you're squaring that 10. And so if you put it in parentheses, then it sees it as a 100, because you're taking negative 10 times negative 10, minus 352. And that gives us a negative 252. So this tells us automatically that we're going to have two imaginary solutions. There's no such thing as just a one imaginary solution. There always has to be two. We are going to take and figure out what it would be if I was to actually just put this whole thing under the square root. What's the square root of negative 252? So I know what to replace over in my quadratic formula. So automatically know that an I can come out. I just need to see what's left under my square root and what can come out with the I. So I know what I came out, so I'm just going to look at that 252. And what's 252 divisible by? Leaving us 126. What's that divisible by? Leaving us 63. What's that divisible by? Leaving us. And what's that divisible by? So we have a set of 2's and we have a set of 3's that can come out. So 2 times 3 is 6. We have a 7 that stayed behind. So we're going to take that information and plug it into the quadratic formula. So what's our variable? What's our variable in the problem? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is a square root of b squared minus 4ac. That whole thing down there at the bottom. So I can replace that entire thing with the 6th I square roots of 7. The negative b is going to get replaced by opposite of whatever my b is. So my b is a negative 10. So opposite negative 10 is 10. Plus or minus 6i on the square root of 7 divided by 2 times my a, which is 8. Does everybody see where I came up with each of those numbers coming into the story? So we are taking that b squared minus 4ac that we simplified and we simplified the square root of it. We're plugging it into the problem. And now I'm going to look and see what can I reduce. So I don't want to think of that as a 2 times 8. That's 16. So looking at these places, oops, is there a number that will divide into those 3 spots? So they're each divisible by 2. And so I am going to divide 6 divided by 2, 10 divided by 2, and 16 divided by 2. So what's 10 divided by 2?
5.
6 divided by 2?
3.
And 16 divided by 2?
8.
I cannot go in the square root when I'm simplifying. I have to stay out of the square root. And so that gives me my answer of 5 plus or minus 3i on the square root of 7 divided by 8. Now, I am not doing this on the computer, so we don't have to go through the different forms and what they're looking for. But those that are going on to ACTs or pre-cal, calculus, this is something to note. This is the same thing. That means the exact same thing that we just had. If they write it in separate fractions, which often they will do when it's complex, they'll put the I at the end off the fraction. And that's so you can work with it in the higher maths. We're going to do one more that we're going to solve with this method. What's different on number 2?
There's no B.
There's no B. So what is A?
4.
What is B if there's not a B?
0.
And what is C?
8.
8.
So first I'm going to simplify that discriminant. Okay. So we have these 2 terms. We're still going to use the discriminant. So the discriminant says that I take b squared minus 4ac. What is b?
0.
So when I square 0, does it change anything?
No.
Minus 4 times 4 times 8. So 16 times 8 is what number?
128.
And so just like we did in the last problem, we're going to take that 128 and we are going to simplify it. We are going to take and put it in the square root and find out what that number is if I would put it in the square root. And so what is the square root of negative 128? So we know there's an I that's going to come out. Is 128 a perfect square? Can I take the square root of it?
No.
No? So let's see what can come out. So 128 is divisible by what? Given us 64, which is divisible by? Gives us 32, which is divisible by 2. Given us 16, 2, 8, 2, 4, 2, and 2. So I'm looking for my sets. I have a set of 2's, another set of 2's, and a third set of 2. What's 2 times 2 times 2?
8.
So that's going to give us 8. That I that we brought out. What's our square root? What's going to be left behind in our square root?
2.
So this whole thing is going to replace our b squared minus 4ac. So we're going to go to the quadratic formula. What's our variable this time? And if you'll notice, when I do my A, B, and C, I always do those with capital letters so they don't get confused with variables. And so A is equal to negative B plus or minus the square root of B squared minus 4AC over 2A. And just so it didn't get confusing with the formula, I went ahead and put them all as capital letters so we can see it. And so the negative b
Is 0.
negative 0, is that a thing?
No.
If you write it as negative 0, I'm not going to count it wrong, but if you need to see it that way, go ahead and write it that way. But just realize it's not really a thing. Plus or minus. And then we end up with 8i on the square root of 2 coming in from the other. And then the formula says 2 times my a, which was 4. And so 0 plus or minus anything, does that change it? Does a 0 change the problem? So that's the same thing as plus or minus 8i on the square root of 2 divided by 8. So now, normally we look for 3 places. What is the one place we never simplify in?
This is square root.
So don't simplify into the square root. We can simplify everything else. So this 8 and this 8 can cancel out. There's not 3 terms to look for this time because there's not that b and not that spot in front of this plus or minus. There's only going to be 2 places to look for. And so those will cancel, leaving you plus or minus I on the square root of 2. That's using the quadratic formula. Would y'all like to learn a shorter way?
Yes, please.
This only works when b is 0. So don't try this when b is not 0. So what does b have to equal for this shortcut method to work?
0.
This works whether it's complex or other types of solutions. So if I was to solve this equation, just solving it for a squared, not worried about the complex solutions, or not worried about the quadratic formula, excuse me. What would I need to solve for and what would I need to move first?
Your A.
My 8. So the 8 would move over to the other side, and it would leave me 4a squared equals negative 8. What would I need to do next?
Square root.
Not square root it yet. Divide by 4. Whatever my coefficient is, divide by it. And so a squared is equal to negative 8 divided by 4, which is what number? Now I want to get that square root. I had to square root it to get rid of that squared. So I'm going to take the square root of both sides. Don't forget your plus or minus. So a is equal to plus or minus the square root of negative 2. How can I simplify this? The I. So a is equal to plus or minus I square roots of 2. If you happen to put your I at the end, this is the reason I typically put it in front so it doesn't happen. If you put it at the end, be careful that your square root symbol does not cover your I. That's like saying you have the square root of negative 1. If you use this and you end up with x squared is equal to 15 over 16, we can still use this method. Take the square root of both sides. X is equal to the square root of 15 divided by the square root of 16. You can split that square root into 2 pieces. That works over division or multiplication. Can you take the square root of 15? Because our prime factorization is 5 and 3. There's nothing that can come out of that. So, plus or minus square root of 15 divided by, can you take the square root of 16? Leaving you a 4. That's your answer. And so I just wanted to show you that one in case it helps you and you don't want to use quadratic formula. There's one of the problems on today's assignment that will be beneficial for.